Imagine a world where electricity flows with zero resistance, where trains hover above tracks, and power grids waste almost no energy. This isn't science fiction, it's the reality of superconductivity. Today, we're diving into this mind-blowing phenomenon that's shaping the future of technology. So what exactly is superconductivity, and why does it matter? Let's find out. At its core, superconductivity is a state where certain materials can conduct electricity with no resistance. Normally, when electricity flows through a wire, some energy is lost as heat due to electrons bumping into atoms. But in a superconductor, those electrons team up in a special way, gliding through the material like they're on a frictionless highway. This magic happens when the material is cooled below a critical temperature, often close to absolute zero, around -273 growth, known as 459 degrees Fahrenheit. At this point, resistance doesn't just decrease, it vanishes completely. The discovery of superconductivity dates back to 1911, when Dutch physicist Kamerlingh Onnes chilled mercury to a frosty -269 degrees and saw its resistance disappear. He called it superconductivity, and it earned him a Nobel Prize. But how does it work? In 1957, scientists Bardeen, Cooper, and Schrieffer cracked the code with a theory called BCS. They found that at super low temperatures, electrons form pairs, called Cooper pairs, that move in sync. This teamwork lets them avoid collisions, creating that perfect, resistance-free flow. Now, here's where it gets wild. Superconductors don't just conduct electricity perfectly, they also expel magnetic fields. This is called the Meissner effect. It's why you've seen videos of magnets levitating above superconductors. That's not CGI, it's real physics at work. So what's the catch? Well, those ultra-low temperatures are a challenge. Early superconductors needed to be cooled with liquid helium, which is expensive and tricky to handle. But here's the good news. Since the 1980s, we've discovered high-temperature superconductors that work at warmer temps, like -135 degrees Celsius, -211 degrees Fahrenheit, using liquid nitrogen, which is much cheaper. Still cold, but a big leap forward. Today, superconductors are already powering cutting-edge tech. MRI machines in hospitals, they rely on superconducting magnets. Experimental maglev trains in Japan and China, they float thanks to superconductivity. And scientists are dreaming bigger. Think ultra-efficient power grids, or even breakthroughs in quantum computing. But we're not there yet. The dream is room-temperature superconductors, materials that work without extreme cooling. In 2020, researchers made headlines with a superconductor at 15 degrees Celsius, 59 degrees Fahrenheit, but it needed insane pressure, like 2.6 million times Earth's atmosphere. So we've got some work to do. Superconductivity is a glimpse into a world of incredible efficiency and possibility. From energy to transportation to medicine, it's quietly revolutionizing how we live. And who knows, the next breakthrough might be just around the corner, maybe even at room temperature. Thanks for joining me on this electrifying journey. What do you think? Could superconductors change the world? Let me know in the comments below. And if you enjoy this video, hit the like button, share it with your friends, and don't forget to subscribe to the channel.